Hello and welcome. Today we're diving deep into one of the most incredible networks in the universe, your cardiovascular system. Seriously, think of it as your body's own personal, high-speed delivery service. It's absolutely vital for, well, for everything, but especially when it comes to athletic performance. Okay, let's get into it. You know, whenever you see an athlete just crushing it, like the swimmer right here, have you ever stopped to think, how is their body actually doing that? That's the big question for today. How does our cardiovascular system step up to meet these insane physical demands? And the whole story really starts with the engine at the very center of it all, the heart. This muscle is just a powerhouse, the central pump that keeps that internal delivery service running nonstop. So let's take a closer look at how this thing is actually built. So the heart is basically this brilliant double pump. You've got the right side with its atrium and ventricle, which takes in all the used, deoxygenated blood from the body through the vena cava. Then you have the left side, which gets all the fresh, oxygen-rich blood and pumps it out to the rest of the body through the aorta. This two-pump system is what makes it so incredibly efficient. Okay, so the path the blood takes is a two-part journey. It's a continuous loop. First, you've got the pulmonary circuit. This is where that deoxygenated blood gets pumped from the heart's right side straight to the lungs to get a refill of oxygen. Then, in the systemic circuit, that newly oxygenated blood comes back to the left side of the heart and whoosh, it's pumped out through the aorta to absolutely everywhere else in the body. It just keeps going, round and round.
So, if the heart is the engine, what about the roads? We need a highway system, right? Well, let's look at this incredible network of blood vessels and the super important cargo, the blood itself, that they carry.
As you can see, not all these highways are built the same. Arteries are like the major motorways. They have to have thick, muscular walls to handle the high pressure of blood being blasted away from the heart. Veins, on the other hand, are the return roads. The pressure is way lower, so they have thinner walls and they have these clever little one-way valves to stop blood from flowing backward. And then you have the capillaries. They're like the tiny little side streets where all the action happens, where oxygen and nutrients actually get delivered. So what is this system actually transporting? Well, blood is made up of four key things. You've got your red blood cells, they're the oxygen delivery trucks. Then you have white blood cells. Think of them as your body's security team fighting off infections. Platelets are the emergency road crew, rushing in to clot any cuts. And all of that stuff is floating around in plasma, which is the liquid that keeps everything moving smoothly. All right, now that we know all the parts, how do we actually measure how hard this system is working? In sports science, it all comes down to a few key numbers that tell us the whole story.
First up is heart rate, or HR. This one's easy. Think of it as the speed of your engine. It's simply how many times your heart beats in 1 minute.
Next, we have stroke volume, or SV. Now, if heart rate is the speed, stroke volume is all about the power. It's the amount of blood the heart forces out with every single pump. And finally, when you combine that speed and that power, you get cardiac output, or CO. This is the big one, the total performance metric. It's the total amount of blood your heart pumps out every single minute. And these numbers can be just insane. An elite athlete's heart can pump over 30 liters of blood a minute during a race. That's like filling up a car's gas tank in less than 2 minutes. And the relationship between them is super simple but so important. Your heart rate multiplied by your stroke volume equals your cardiac output. So, if your muscles are screaming for more oxygen, your body has two choices. It can make the heart beat faster, or it can make it pump out more blood with each beat. You know, here's a pretty cool thing you've definitely felt before. Ever notice your heart starts pounding before a big race or a game even starts? That's a real thing. It's called the anticipatory rise. It's your body giving itself a little head start, releasing some adrenaline to get the whole system ready to go. Speaking of clever body systems, the way it manages its resources during exercise is just brilliant. It's a process called vascular shunting, and you can basically think of it as a super smart traffic management system for your blood. So how does this traffic control work? Well, it uses two main tools. During exercise, you get vasodilation. That's the widening of the blood vessels going to your working muscles, which floods them with oxygen. At the exact same time, you get vasoconstriction, which is the narrowing of vessels to places that don't need the blood right then, like your digestive system. This whole shunting process is just a genius way to get resources exactly where they're needed most. Okay, that was a lot of information. Are you ready to put that new knowledge to the test? Let's run through a couple of exam-style questions to see how these ideas work in the real world. All right, first question is up. Which one of these is the right definition for stroke volume? Is it A, B, or C? I'll give you a second to think it over.
And the answer is B. Remember, heart rate is beats per minute, cardiac output is blood per minute, stroke volume is the specific amount of blood pushed out with each individual beat. If you got that one, awesome job.
Okay, let's try another one. This is a recall question. Can you list 3 key features of veins? Think back to their structure and what their main job is.
A really solid answer would hit on these 3 points. Veins have valves to stop blood from flowing backward, which they need because the blood is moving at low pressure. And that low pressure is also why their walls are so much thinner than artery walls. See, every feature is there for a reason.
All right, time for the big finale. This is a more complex question. It's asking you to take everything we've talked about and apply it to a real-world scenario. How does blood redistribution help a hockey player in the middle of a game?
So to nail a big, non-mark question like this, you need to show 3 levels of understanding. First, the basic knowledge. You name the process, vascular shunting. Second, the application. You explain how it works, diverting blood from places like the gut to the working muscles. And finally, the evaluation, the so what. You connect it directly to the hockey player, explaining that more oxygen to their quads means more energy for skating, for shooting, for winning the game. That's how you build a top-tier answer.
So we've seen how the cardiovascular system is this amazing delivery service, getting fuel and oxygen right where it needs to go, right when it's needed. But that leaves us with one final big question to chew on. Where does all that oxygen come from in the first place? What other system has to work perfectly with this one to make peak performance possible? Something to think about. Thanks so much for joining me today.